warahmatullahi wabarakatuh. Good morning, everyone. Today I would like to explain about the carbon adsorption. First, I would like to introduce myself. My name is Haikal Ramadhana Akmal with student ID 2009. So, let's jump into the topic. So, for the introduction to carbon adsorption, the carbon adsorption is one of the most widely used technology for controlling volatile organic compound. In industrial exhaust gas, the process removes pollutant by trapping the VOC molecules on the surface of activated carbon. It is especially useful when strict emission standard must be achieved or solvent recovery is desired. The technology combines high efficiency with the relatively simple operation. So, carbon absorption can control VOCs, VOC emission from industry, high removal efficiency, low solvent recovery, and also commonly used activated carbon. For the fundamental of the adsorption occurs when the gas molecule attack to the surface of the solid material due to attractive force. As VOC molecules move from the gas phase to the carbon surface, heat is released. The adsorption capacity depends on the several factors such as concentration, molecular weight, and temperature. Higher temperature generally reduce adsorption performance. So here's the factor the affecting adsorption. First one is the factor that affect on absorption. For the VOC concentration is increased, for the molecular weight is increased, for the polarity is increased, and for boiling point is increased, but the temperature is decreased. That is the effect on adsorption. So in activated carbon as a adsorbent, the several absorbents are available for the air pollution control, including silica gel, activated alumina, and zeolites. However, activated carbon is the most commonly used material because of the large surface area and porous structure. These properties enable it to capture a large amount of the VOCs effectively. Activated carbon can also be regenerated and reused. Type of the carbon adsorbers. The carbon adsorption system are available in several configurations. The most common type used in air pollution control are fixed bed adsorber and canister adsorbers. Other designs include the moving bed, fluidized bed, and chromatographic system. Each configuration is selected according to the flow rate, VOC concentration, and operational requirement. Here's the type of the absorbent. You can see the fixed bed and application in large-scale system. For the canister is small and intermittent stream. For the moving bed is continuous operation. For the fluidized bed is for the high mass transfer, and for the chromatographic apply in the specialized use. For the fixed bed adsorbers, is the fixed bed absorbent are the designed to treat continuous VOC containing gas stream over the wide range of the flow rate. The gas passes through the stationary bed of activated carbon, where the VOC are captured. Like this system over the high efficiency and can be operated continuously or intermittently. They are commonly used in chemical and manufacturing industry. For the adsorption and regeneration cycle, one of the carbon becomes saturated, it must be regenerated before use. Regeneration is typically carried out using steam or hot gas to remove the adsorbent VOCs. After disruption, the bed is dried and cooled before returning to surface. This cycle allows activated carbon to be reused multiple times. For the canister adsorbers are generally used for the smaller and intermittent emission. For the source that such as storage tank, fan, unlike fixed bed system, regeneration is usually performed off-site. When the carbon becomes saturated, the canister is replaced and sent to a regeneration facility. This design provides operational simplicity and flexibility. Next, we jump into the absorption isotherms. The isotherms describe the relationship between the VOC concentration and adsorption capacity at equilibrium. The fluid-leach isotherm is commonly used for the activated carbon system. It showed that adsorption capacity increased as VOC partial pressure increased. The temperature also affect the equilibrium performance. And next is about the design parameters. The performance of the carbon adsorber depend on the several important design parameters. These include the gas flow rate, VOC concentration, absorption time, carbon capacity, and humidity. Like proper selection of these parameters ensure the efficient VOC removal and cost-effective operation. Pretreatment may also be necessary when the particulate of moisture are present. So here's the main design parameter. For the parameter like flow rate, the importance is the determines the fissile site. For the VOC concentration, the importance is determine the carbon loading. For the absorption time, the importance is the affect the regeneration frequency. For the carbon capacity, is the importance is the determine the carbon quantity. And for the humidity, the important is the influence efficiency. For the carbon requirement estimation, the amount of activated carbon required depend on the VOC loading, absorption time, and carbon working capacity. Working capacity is usually estimated as approximately 50% of the equilibrium capacity. This safety factor helps prevent premature breakthrough of the VOCs. The accurate carbon estimation is essential for proper system design. For the capital and operating cost, the cost of the carbon absorption system include the activated carbon, absorption vessel, fans, pump considers, and installation. Activated carbon and vessel often represent the large portion of the investment cost. Additional expense include maintenance, electricity, steam, and carbon replacement. Proper design can significantly reduce operating costs. For the major cost component, here's the component is about the first one is the activated carbon. The cost impact is high. For the absorber vessel is the cost impact is high. For the fan and motor, cost impact is medium. For the condenser, cost impact is medium, and for the instrumentation, the cost impact is low. So here's the advantage and limitation, and also the application of the carbon adsorption. Here, for the advantage is the high VOC removal efficiency, solvent recovery potential, and proven technology. For the limitation is required regeneration, sensitive to moisture, and carbon replacement costs. And for the application, it can be applied in chemical plant, pharmaceutical industry, fuel storage facility, and paint and coating industry. I think that's all of my presentation today. Thank you for your attention. I hope you learned something new today. Assalamualaikum warahmatullahi wabarakatuh.